Welcome to part 4 of the Recursion video series. Today we'll be looking at how to solve the palindrome problem in Java using a recursive solution. So just a quick disclaimer before I go ahead. Most of the videos I'll be presenting, I'll be focusing mostly on the code problem. I'm not adding checks for edge cases like if S is null or S is empty. But if you're actually solving this in an interview, you need to add checks for all of that and also write unit tests at the end. But in this video series, I'll be just focusing mostly on the recursion part of the code. So in today's problem, we'll be solving a palindrome. So palindrome is basically something like this. You might already know. A palindrome is basically something that reads this way and this way the same. So if you read it like this, it's madam. If you read it this way, it's madam. Another example would be mom. You read it either way, it's the same. So now this is something that is not a palindrome. Like if you read it this way, it's blue. If you read it this way, it's something else. So this is not a palindrome. This is a palindrome. So this is a palindrome. So with problems that can be solved by a recursive solution, one thing to observe is that you're solving the same problem again and again with different inputs. So one thing you'll notice in many of the backtracking and recursion based problem solutions on lead code is that ultimately when you come up with the solution, it's very often very few lines of code if you solve it a recursive way. Like this itself is just like about 15 lines of code. So once you understand how it works, it's actually very simple. By the end of this video, if you're not able to understand, it's not because recursion is hard, it's probably because I'm not explaining it very well. Once you understand it, you'll yourself come to the same conclusion that it's actually very, very simple. But getting it the first time is hard, and for that it takes a little bit of practice. Like you might have to solve like 15-20 problems in recursion, but once you get it, after that it's very simple. So anyway, let's solve today's problem. So if you want to solve this recursively, any recursion based problem, the observation to make is that you're solving the same problem again and again for different input. So what I mean by that, suppose you want to check if this is a palindrome. You check this and this, are they equal? Yes. This and this, are they equal? Yes. And when it's one letter, that's obviously you don't have to check. So this is a palindrome. When you start with this, say suppose your word is like this, A blue, A. This and this, is it equal? Yes. This and this, is it equal? No, it's not a palindrome. So basically what you're doing, you're solving the same problem again and again where you're comparing two characters. So, and the input is different. So that is a classic place where you use recursion, where you're solving the same problem again and again with different input until you reach a base case. So base case in our case would be when you reach the last one or two. So in this case, MADAM, compare these two, you're at the last one. If you reach till here without any faults, that means this is a palindrome. So that is one base case where you come with just one letter, then that is a palindrome. Or say you have a word like this, when you're in the last two letters and if they're equal, that's palindrome. These two are equal, correct? These two are equal, these are the last two, then it's a palindrome. So any recursion based problem, you'll have a base case, otherwise it will keep going forever. So in our case, the two base cases are either as you keep checking, you are left with only one letter, or you're left with two letters and they're both equal. So those are the two base cases here. I keep on checking. So this problem, the way I will solve is just like I solved on the board. If you pass in madam, I check whether these two are equal. Yes, these two are equal. Yes, is this equal? Is this one? Or if it's one, then it's a palindrome. If it's two, if they're equal, it's a palindrome. And every next call, your input, you're just stripping off this and passing this, stripping off this, passing this. So another key point actually to remember when solving recursion based problems, one way to think of it is in every stack frame. So I'm going to get to the stack frames in a minute. every stack frame you solve a little bit of the problem and pass the rest of it to the next stack frame. Then the next stack frame will do the thing, same. It will solve a little bit of the problem and pass the rest to the next stack frame, and it will keep going that way until it reaches a base case. So let's see how it happens here. The same problem in the stack frame. So the main will call is palindrome and pass in madam. So I haven't put the main code here. So the main code is not here, but when you call from main, you're just calling this method and passing in the string madam. So when you start running main, there is only one. So none of this is there in the stack frame initially. When you start running the code, when you come into main, you just have one stack frame, which is for main. I've put the name here for main. So main will call this method. So when it calls this method, another stack frame is created and you're passing in madam to this method. Now, like I said, every stack frame, we solve a small part of the problem and give the rest to the next one. So the first stack frame, when I pass madam here, the small part of the problem I'm solving, first you check the base cases, they're not met, you come here. So all I'm checking is the first letter and last letter the same. So you have madam. So if this is not the same, I know right off the bat it's not a palindrome, I can return false, which is here. But what I do is these two the same. So I'll only solve one part of the problem in this stack frame, which is I'll only check for these two. If it's the same, I'll pass the rest, the entire rest to the next stack frame. So I check here, first two letters same, yes, pass the whole thing to the next stack frame where I strip off these two. So I've already checked this in the first stack frame, right? I'll strip that off, pass it to the next stack frame and tell him, you go check whether this is a palindrome or not. So this stack frame will say, okay, I will check. But then this stack frame does the same thing because every stack frame is lazy. You can think of it that way. They'll only do one part and give it off the rest to the one above them. So this guy will again check. Are these two the same? He'll say, okay, they are the same. So he'll strip off these two and then pass the remaining string to the next stack frame above. Check, say that you go check whether this is a palindrome. So when we come here, we reach the base case. So we know that if the length is 1 or length is 2, we'll have an answer. If length is 1, it's a palindrome. If length is 2, if the first and second characters are equal, it's a palindrome. But in this case, length is 1, this guy returns true. This guy returns true to this guy. So this guy will, so every stack frame can only interact with the one above and the one below it. It cannot go directly. So that's also an important thing to remember. This guy tells this guy it's true. So this guy will pass that information here and say it's true. This guy, another one thing. When you go from one stack frame to the next, that goes off the stack. Okay, so when this guy returns, this whole thing disappears. Only these three will remain. Then this guy will return true. If this whole thing will disappear, only these two will return. This will return true, and then you have the answer. Suppose you have some other string where, like I had said earlier, like say S A B B X S. So here you will start, these two will be equal. The first stack frame will rip off these two, pass it to the next stack frame. The next stack frame will check these two and check that these are not equal. So it will return false. So whatever that returns, this stack frame will return to the next one. It will go all the way down. So that covers the palindrome part of recursion, palindrome problem in recursion. So next lecture onwards, I will look at decision tree. So decision tree is taking it one level further. But once you learn decision trees also, that pretty much will cover every kind of problem you can come across in recursion and backtracking. Alright, thank you.